Okay, so introduction to story tables. We have an equation. There's an equation in front of us, 3x minus 2 equals 10. If your brain is trying to solve that equation, I would invite you to tell your brain to just chill for a moment. And instead of trying to solve this, what we're going to do with the story table is tell the story of X, and then we're going to use guess and check in order to see what might work for X to make this true. But again, I invite you to don't try to solve this, because let's see what comes up. So by story table, we're telling the story of X as it moves through this equation. So in the first column, we just have X because that's our variable, what we're trying to find. And then so the first thing that happens is then it becomes 3x. It's multiplied by 3. And then the next thing that happens is that 3x, that 2 is subtracted from it. And then after this whole story has happened, the result that we're expecting is 10. So now what our job is to really just do some very broad guessing and checking about what X might make this true. And so I don't know, does someone just have a random guess to start with? Let's just stay with whole numbers, kind of keep it simple, just to introduce this idea. What's an X that we could try?
There are 3 farmers. No, there are some farmers. I don't know. Sorry.
Can you see my screen, Maya?
Yeah.
I feel
don't
like
know what story I'm supposed to tell about X.
Well, the first thing that happened, we're telling the story of X within this expression, but we're not, this is not the same as making a scenario about it. It's not like that. Although, I mean, that might be an interesting idea to explore. This is like the mathematical story of X inside of this expression.
Mathematical story. Okay, somebody.
So how about 2?
Okay, thanks, Eric. So if X is 2, so Eric, just then stick with me here. So if X is 2, then 3 times X would be 3 times 2, so
6.
6. And then this here's the 6, but then we're subtracting 2 from it. So Eric, what is the what's the
6
result?
minus 2 is 4.
Yep, 6 minus 2 is 4. And then what we're looking for is this 10. And but we only got 4. So I just, I like to say no, not it. Nope.
Can I?
Yes.
Can I say? How about X equal 4? X equal.
X equals 4.
Yes.
Okay, let's do it. Okay, so if X equals 4, then what does 3, then what does 3X equal? What is it at this place?
12.
Okay, 3 times 4 will give you 12. And then here we are taking 12 and then subtracting 2. So what have we got?
10.
10. Okay, so already by the second try, this 10 was what we were looking for, and we have arrived at that answer. So then you just say yes. And then, so in the equation of 3x minus 2 equals 10, then we can say that x, we've solved the equation to say that x equals 4. We got this in 2 tries, maybe because Combe knows some things about how math works. Sometimes it takes more tries. But this is just an introduction to how it works. So does anyone have any questions about like what is a story table and how does it work, or how does it work? So there are different
Oh.
ways to use these, but this is how I have used them with students.
I think somebody
Sorry.
had a question.
Yeah, go ahead. Was that you, Comb?
I was just trying to say, I'll just look at the equation there. Then what can I plug instead of the x? Then minus the 2, then would be the 10. That's what I was thinking, and then that's how I come out with 4.
And I wonder how you learned to think that way. I wonder how you. I wonder where you learned to think of that. Because that was several
3x.
steps.
Right, 3x would be the just the 3 times x. If the x value can be the anything, but when we subtract 2, we are looking for the 10. So I look at it from the kind of backward, not from the just beginning x.
So to check, to make sense of our answer, the way that Comb is saying, if we're saying x is 4, then 3 times 4 is 12, and then you subtract 2 from that 12, and then the answer is 10. So there's the beginning. Hold on, I need to see. It sounds like someone else is arriving.
I just decided that, I decided to go with 5 because I knew it needed to be double. It couldn't be 2, it had to be double 2. So I chose 5, and then that didn't work.
Why did you say, why are you saying double?
Well, because you got 4 here. You made x2, and it turned out to be, and then the whole thing turned out to be 4. So we needed to increase the number. So I decided to increase it by 5. That didn't work. So then, of course, the next number would be 4. That would be a note. So
Hey,
then
Maya, your audio is a little low. I was wondering if there's anything you could do on your
yeah,
end. We're having trouble hearing
I'll
you.
get it up. Sorry.
I can hear her okay, Eric.
No,
Is that true?
I did make it low. Can you hear
Okay.
me better? No?
That's better, yeah.
So this is how it works, and sometimes you have to just do a couple guesses. And I guess I just want to say this directly. If you know a different way to solve it, then don't use that way, because what we want to do is let the story unfold so we can see what patterns come up. So it's just good to try things, and you can adjust. You can try to make better and better guesses as you go. So we'll try another one. So this time we have a different kind of equation. This equation says 3x plus 2 over 5, and we want it to equal a whole number. So if we tell the story of x, so the first step, hold on, I'm just looking. Welcome, people that are arriving. Welcome, Vera. Welcome, Ayantu. Okay, so here's the equation. 3x plus 2 over 5 will equal a whole number. So if we tell the story of x, first we just have, it's just x. And then by multiplication, it's 3x. And then by looking at the full numerator, it becomes 3x plus 2. And then once we have that numerator, then we're dividing it by 5. So then it becomes 3x plus 2. I'll just in parentheses to be clear, all of this is happening, and then it's divided by 5. And then what we want for the result is a whole number. So could we hear a guess from someone who hasn't said a guess yet? And first guess is kind of, you just have to try something. Go ahead, Sarah.
I was gonna say that the last equation 4 was the solution, so maybe we should start with 4 this time.
Start with 4. Okay, so if x is 4, then 3x is
Then 3x is 12,
12. 3x plus 2,
is 14.
12 plus 2, which is 14. Oh, hold on. I want this all to be on the screen. Okay, so then we have 14 divided by 5, and I would like to just leave it as an improper fraction so we don't get kind of hung up in the world of doing things with simplifying fractions. And so Sarah, is 14/5, is that a whole number?
No.
Nope. Not yet. Thanks for going first. Okay, so does someone have another try? Gina,
Yeah.
what's up?
All right, let's throw a 9 in there.
Okay, try 9.
Mhm.
So, whoa, 9. So then 3x is
So that would be 9. 3 times 3, yeah, 9. Is it?
just do that more slowly in your brain. So if x is 9, so then this is 3 times 9.
Oh, is that 18? 27?
Yep,
Okay.
yep. So 3 times the 9 gives you the 27, and then
Plus
take
the-
that. Go ahead.
That's 29.
Mm-hmm.
So now we're gonna divide the 29 into that 5. And we do not get a whole number.
Nope. No, thank you. Not yet.
Yeah.
We'll just, nope. Okay, so, Gina, do you think, do we have any, did, with 1, you don't have any clues, but with 2, you can sometimes have clues? Are there any clues, or are we headed in the right direction, or we kind of can't tell? Are you seeing anything?
I don't know. I think we put in a bigger number there. We're just gonna end up with another not whole number.
Mm-hmm. Will someone else do a try, please? What's another number we could try?
I'm looking for a prime number. I'm looking for an uneven number that's not prime.
Okay,
What is that?
an odd and not prime.
Yeah, odd
9
and
already
not-
got used.
Oh, 9,
that's-
that's it, okay.
Oh,
Yeah.
1. Gina says 1. That's kind of interesting. 1 is odd and, who
It's
knows that rule? 1 is not prime, right? By definition? I don't know. Maya, can we try 1, or did you think of a different
Yeah,
number?
1 is good.
Okay,
1 is not considered a prime number by definition.
okay. Thank you both.
Mhm.
So whoever feels like talking through this one. So if x is 1, 3 times 1 gives us
the 3.
Mm-hmm.
That's 5. Plus the
3
2.
plus 2 is 5. Yep.
Mhm.
Ah, now we have 5 over 5. So is this a whole number?
We're gonna get 1.
Nice.
But that's not a whole number, right? It is?
It is a whole number. It's not a fraction, or it doesn't have a decimal.
It's a whole number?
Yes.
Maya, what are you looking at? What is the thing that you're wondering about when you say it?
It's x is 1. 3 times 1 is 3. 3 plus 2 is 5. 5 divided by 5 is equal to 1. I didn't know it was a whole number. What's a whole number?
When we're looking for a whole number, we're looking for that 5 divided by 5, that it equals 1, that it equals a whole number rather than a fraction that can't be
Oh,
simplified.
Oh, I see.
Not only did we get a whole number, but we got the number we started with, which is pretty cool.
Uh-huh. I think I want to push this a little bit, and I just wonder, can we make another one? So when x equals 1, then this expression equals a whole number. We've found it. We found 1. And I wonder if there are others. And let's just spend a little more time with this and see what we can uncover. And it's really hard for me to talk and like highlight at the same time. Okay, so 1 it works. Will someone do another try? What?
About
11.
Okay, 11. So if x is 11, 3x becomes, please continue.
33.
Thank you, Vera. And
Let's do
3x,
35. So 35 over 5.
okay, 35 over 5. Is this a whole number?
Yes.
Yeah. 7.
Equals 7. Yay, again. You can decide what words you want to use, but I like these. So 11 is 1. So now I wonder if there's a pattern and we know how to do this, or if it was Vera, how did you choose 11?
I tried the other ones first and it didn't work, some of them. So I thought if it works with 1, then how about I try with 11 and it worked.
Okay.
So, I mean, I don't know about 21. Like, you want to try?
Oh,
How
so
about
you're
try
So
with 31?
maybe-
13.
Okay.
Try with 13 because it is a prime number. It's a-
okay. 13 makes
It makes 39.
30 times 3 makes 39, and then if you add 2, it makes
41.
41, and then 41 over 5 equals
No.
nope.
So maybe we did find a pattern.
Comb is saying 6. Is that right in the chat?
Okay.
We-
6.
Let me-
yes.
Yes, 6. Okay, so we can try 6. Hold on, let me do I want
Oh, it
to insert some spaces here. I just want to do better with what you can see on the screen. I think we're good here. Okay, so then 3 times 6 makes
18.
and then add 2, so you get
20.
20 divided by 5
It's a whole number.
is 4, which is a whole number.
4.
Yay. And I'll just highlight it. So this also worked.
Whoa.
6 worked. Okay.
What works?
So let's pause for a second. Let's pause for a moment. And let me do something here. I'm gonna I'm just gonna put the 3 that worked all adjacent so we can look at them all together. So we just take a moment and look at the x values that made a whole number in this equation. So 1, 11, and 6. Take a look at the x column, but also take a look at all the columns and just see if you notice any patterns or suspect any patterns.
1, 7, 4. 4, 7. 1, 4.
Well, I see a pattern that maybe I
Okay.
can share.
Please.
If you look in the third column, the 3x plus 2 column, 5, 35, and 20, they're all multiples of 5.
Thank you,
Okay.
Eric.
Right.
Yes.
Something to do with that
Eric.
5.
I wonder if that is a coincidence, or I wonder if we could test it. I wonder if we can test it with a new number and kind of check out your conjecture or check out your idea that way. So I'm just going to say another multiple of 5 is 10. Let's see. I don't know what's going to happen here. So Eric, if 3x plus 2 is 10, then what is 3x?
Oh, you want me to move backwards?
Yes.
If 3x plus 2 is 10, then 3x must be 8.
Must be 8. So then
Each-
x would be what?
I don't know.
Okay, then X would be, oh, man. How would you make that?
2.66.
No
Is
way.
2.66?
No, I don't know.
Could we also just say that it's a third of 8?
A third of
We have
8?
to say exactly, or I mean, actually, that is
2.5,
exactly what it is,
2.5,
right?
and 2.5 is 5. And 2.5 is 5, 7.5.
8/3. Okay, so but I think to me, I'm just noticing that it didn't work. Like my idea of like, oh, what if we just put in a multiple of 5 in this column and then kind of work backward? It gives us a number that could work, but it doesn't necessarily like come out to a friendly whole number. So I don't know. That was just like an idea that I wanted to try.
I mean, I don't know if this is part of this, but it seems like we want the last number to be a whole number. I mean, we want it all to equal a whole number. It seems like we also want x to be a whole number. I mean, you told us to start there, right?
Okay.
But
And
it feels
yeah.
like I kind of want x to be a whole number, but
Mhm.
I don't know if it has to be.
I think one of the beautiful things about algebra actually is that you can work with numbers that you don't fully know or can't fully describe. So like even if we don't, even if we can't give this number an exact name, calling it 1/3 of 8 or 8 divided by 3 or 8/3 are all still ways of describing a single quantity, single amount.
Okay.
I'm just laughing at the chat. So this is the last of us working all together as a group before we split into groups. So I'm going to ask you to type some reflections about your experience. Here's my question. Do we need to do one or two more tries from the beginning here? Like, would you like to do one or two more guesses before we reflect on our experience, or are you good?
I'd like to do one more guess.
Okay. Do you have a guess?
So this is 5, 5, 20, 35. 5, 20,
Did you guess
35.
5?
No. No, I didn't put in.
You're
5,
thinking
but
about it?
I wasn't thinking about it, but go ahead, yes.
I guess we haven't done that yet. 5, 15, plus 2 is 17. 17 divided by 4, nope.
I was just thinking of, you did 5, 20, and 35.
Oh, I see. You're
That's what I was
looking for a
thinking.
relationship among these that worked.
Yeah, I'm thinking maybe they don't, all the multiples of 5 don't work.
How about 15?
Ah, what do you say that again, or say more about that?
I said, can we try 15?
Okay, so 15 as our try right here for x?
Yeah, yes.
Okay, 15. So then this would be
45.
3, so 45, and then
Doesn't work.
Oh, plus
So it has to be
47.
5, 20, and I don't know why 35 works, but maybe 35, maybe, maybe 40.
Is there, I don't know, I'm just like, is there anything in common among the X values that did work?
All multiples of 5.
These are, but I'm wondering if there's anything in common among the X values.
I think is it 6 a prime number? No.
Nope. Let's, I think
Yeah,
we've
yeah.
had, I want to make sure that we
Adding
have,
5. Oh, sorry.
Vera, say it again.
I think it's adding 5. It's like 1 plus 5, 6, and 6 plus 5, 11. Or
Okay. So
The-
there's a
Ah.
difference of 5 between among
I'm
these.
just, yeah.
So
Yeah.
Vera, then I kind of want to try the next one. So
And it's 16.
1 plus 5 is 6, and then you add 5, you get 11, and then you add 5, and then you get 16. Let's see what happens. I'm just curious. 16 times 3,
38. I'm sorry, 48. Sorry.
48.
16 times 3 is 8 times 6.
It
Yes.
worked. Very good.
And then add 2.
48. No, I'm sorry. 16 times 3, 48.
Thank
So,
you.
yeah,
Hmm.
10.
Yes.
Oh, okay.
Yeah. No? How can that be no?
That's me stopping paying attention for a
Uh,
minute, 30 seconds, for 10 seconds.